Hi and hello. We're going to begin our new unit on quadrilaterals, the study of four-sided figures. Any quadrilateral has four sides. That's our definition. So we have all different kinds of quadrilaterals, the regular ones, the irregular ones we've seen before, one we haven't seen before, and even these weird ones that are bent inwards. We're going to focus today though on parallelograms. Parallelograms are a special kind of quadrilateral. You can tell by the name, but opposite sides have to be parallel. That's our definition of a parallelogram. It's a quadrilateral with parallel opposite sides. Now there are special kinds of parallelograms. We'll get to those later, but like this square and rectangle. So let's begin by taking a close look at some of the properties of quadrilaterals. There are four specific properties of parallelograms that we want to explore today, and we'll demonstrate each with this parallelogram for reference. So, property the first. Opposite sides, again, have to be parallel for any of these to be true. Property the first, opposite sides are congruent. Similarly, opposite angles are congruent. So what that means, say that angle A is 50 degrees, then angle C is also 50 degrees. We can do the same thing with segment lengths. If AD is 10 inches long, then BC is also 10 inches long. Property number 3, consecutive angles add up to 180 degrees. They are supplementary. So if angle A is 50 degrees, then angle B has to add up to 180, so it's 130 degrees. And property number 4, diagonals bisect each other. So our diagonals here go through the middle of the shape BD, AC. Those two segments cut each other in half. They will meet at their midpoint. So now let's take a moment to try to apply these properties. We've got a couple of examples we're going to work through. So let's start with this problem where if we have angle E is 146 degrees, angle G is 4x plus 10, we know opposite angles are congruent. So angle E has to be congruent to angle G. They have to have the same measure. So we know 146 must equal 4x plus 10. Then we'll just solve this algebraically, subtract the 10 from both sides, and we have 136 is 4x. And then dividing both sides of the equation by 4, we have x is 34. Moving right along, example number 2. Here we have a side that's 19 and a side that's 20x minus 1. Assuming this is a parallelogram, again, opposite sides have to be parallel, we know that our opposite sides are congruent. Our opposite sides are the same length. So that means that UV has to be the same length as TW. So 19 is equal to 20x minus 1. Gives us, adding 1 to both sides, gives us 20 is equal to 20x. Dividing by 20 gives us x is equal to 1. All right, and example number 3. Here we have parallelogram PQRS and the diagonals given. The diagonals meet at point V. We're told VS is 9 and QS is 2x minus 2. And we know the diagonals bisect each other, so that means that QV is the same length as VS. How that helps with this problem, though, is that tells us VS is half of QS, or 2 times VS is equal to the whole thing QS. So then we can plug in what we know. We got 2 times 9 is equal to 2x minus 2. Simplifying the 2 times 9 is 18 is equal to 2x minus 2. If we add 2 and then divide, we end up with x is equal to 10. All right, those are our properties of parallelograms. Now I want to talk about conditions of parallelograms. Or, in other words, we want to prove that a figure is a parallelogram. So far we've seen what we know about parallelograms, and these conditions, these proofs, are going to look very similar. We can prove a figure is a parallelogram if all four sides are opposite pairs of sides are congruent, or if the opposite pairs of angles are congruent, or if the consecutive angles are supplementary. Or if the diagonals bisect each other. So these should look very familiar. These are our properties of parallelograms. Turns out that they are enough to show a figure is a parallelogram, but you only need one. If a quadrilateral has any one of these properties, it has all of the other three. So let's go through and try to prove some figures are parallelograms. So we'll start with this one, GHIJ. If the problem says we're given two pairs of parallel sides, we're asked if the other two sides are congruent, is it a parallelogram? And yes, it matches that first condition that all opposite sides are congruent. So from here, we know that everything else is congruent, right? We know that angle G is congruent to angle I, angle H is congruent to angle J. We know everything is parallel, but only if the opposite sides are congruent. All right, let's check out example 2. Here we have a pair of parallel sides, good, a pair of congruent sides. However, try this as you might, we can try to split this up into triangles. We just don't have enough. There's no way to get both pairs of sides are parallel or both sides of pairs are congruent. It might be a parallelogram though, it sure looks like one, but this description actually matches a figure we'll talk about later. Let's check out example 3. Here we have congruent segments on the inside, and this is pretty directly yes. We have the diagonals bisecting each other, so this is definitely a parallelogram. All right, one more example. Here we're given some values. We're told A is 2.4, B is 9. We're given some expressions about segment lengths and angles. We need to verify that this is a parallelogram. So what we're going to do is we're just going to verify that if A is 2.4, that our sides are congruent, right? Does 7A actually equal 2A plus 12? So let's just plug everything in. 7A is 7 times 2.4, which is 16.8. And then we'll plug in 2A plus 12. 2 times 2.4 is 4.8, plus 12 is 16.8. That one's good. Now let's check our angles. We know that our angles have to be supplementary. We know that angle Q plus angle R should be 180 degrees. So we'll have 10B minus 16 plus 9B plus 25 is equal to 180. Combining some like terms, we'll have 19B plus 9 is equal to 180. We can substitute in the 9. 19 times 9 is 171. So we have 171 plus 9 is equal to 180, which is perfect. And thanks for watching.